Good morning, guys. We're going to start chapter 5.2 notes, which is over medians and altitudes. So looking at the first theorem, we have the centroid theorem that states the medians of a triangle intersect at a point called the centroid. That is 2/3 of the distance from each vertex to the midpoint of the opposite side. In this example, if P is the centroid of triangle ABC, then AP, so this part right here, is 2/3 AK. So 2/3 AK, which AK is the entire part. BP is 2/3 BL, and CP is 2/3 CL. Or sorry, CJ, that's a J. So let's look at example 1 using this theorem. In triangle ABC, Q is the centroid and BE, so this entire thing is 9. Find BQ and QE. So we know that BQ is 2/3 BE. Well, since BE is 9, BQ is equal to 2/3 times 9, which is equal to 6. Okay. We also know that BQ plus QE is equal to 9 because both of those sections add up to the full section. So we have 6 plus QE is equal to 9. If we subtract 6 to both sides, we have QE is equal to 3. So we found QE and we found BQ. Okay, let's look at example 2. Again, we're using the centroid theorem. So it says in triangle JKL, PT, which is this section right here, is 2. Find KP. Well, we know that KP is equal to 2/3 KT. So KP is equal to 2/3 KP plus PT. Because KP plus PT, excuse the bell. So KP plus PT is equal to the entire part KT. So we have KP is equal to 2/3 KP plus 2, because 2 was PT. So then we have KP is equal to 2/3 KP plus 4/3. And all I did was distribute the 2/3 in. Well, if I subtract 2/3 KP to the other side, 1 KP minus 2/3 KP is 1/3 KP. Oh. KP, there we go, which is equal to 4/3. Well, in order to get rid of a fraction, we can either divide by that fraction or multiply by its reciprocal. So the reciprocal of 1/3 is 3. So I'm going to multiply both sides by 3. So I get KP is equal to 4. That's my answer. Okay. Now let's move on to the next example. Now we're doing a real-world example. So it says a performance artist plans to balance triangular pieces of metal during her next act. When one such triangle is placed on the coordinate plane, its vertices are located at 110, 50, and 95. What are the coordinates of the point where the artist should support the triangle so that it will balance itself? So what we need to do is we need to find the centroid of the triangle with the given coordinates. This point will be the balance point. So I'm going to graph and label the triangle with the vertices A, B, and C. So that's what I'm going to do first. So I'm going to graph 110. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So up here, and that's A. I'm labeling that one A, B, and C. Okay, 5, 0. So 2, 3, 4, 5 is B. And then 9, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. So about right here. So if I connect all of these vertices, this will be my triangle. So what we need to do is we need to find the midpoint D on the side of AB. So remember, we're using the midpoint formula to find D. So D is potentially going to be between A and B. So what we're going to do is we're going to do D, because that's the point we're labeling it, 1 plus 5 divided by 2 over 10 plus 0 divided by 2. Remember, it's x1 plus x2 over 2, y1 plus y2 over 2. If you are still struggling on memorizing formulas, please make sure you are doing that on your own time. So then this becomes the point 1 plus 5 is 6, 6 divided by 2 is 3, 10 plus 0 is 0, 10 divided by 2 is 5. So this is the point 3 comma 5. So 3 comma 5, which is about 1, 2, 3, 4, 5. So about right here, this is D. Notice that DC is a horizontal line. The distance from DC is 9 minus 3, or 6 units. Because D is at 3, C is at 9. So the distance from D to C is equal to 9 minus 3, which is 6. If P is the centroid of triangle ABC, then PC is equal to 2/3 DC. So PC is equal to 2/3 DC. Well, you know DC is 6, so 2/3 times 6 is going to give us 4. The coordinates of P are now 9 minus 4. So the coordinates of P, so P is going to be 9 minus 4, comma 5, which is 5, comma 5. So now I'm going to graph that. So 5, again, excuse the bell. So that means we found the centroid of the triangle, which is P, 5, comma 5. Okay? Now let's look at the next part. So the lines containing the altitudes of a triangle are concurrent, intersecting at a point called the orthocenter. The lines containing altitudes AF, so here's line AF, CD, and BG all intersect at point P, the orthocenter of triangle A, B, and C. So let's use that concept to do example 4, which is our last example. So it says the vertices of triangle FGH are labeled on this coordinate graph. Find the coordinates of the orthocenter of the triangle. So in order to do that, we need to find an equation of the altitude from F to GH. Okay? The slope of GH, so GH, which is here, let's go ahead and find the slope of this line. And since it's on a graph, we can count it. So 1, 2, 3, 4, 5, 6 down. 1, 2, 3 to the left. So this is -6 over 3. So the slope of GH is equal to -6 over -3, which is 2. So the slope of the altitude, which is perpendicular to GH, is going to be -1/2. So the slope of the altitude is perpendicular to GH, so it's going to be -1/2. So if we were to find that line, we would have to use the point slope formula. So y minus y1 is equal to mx minus x1. Well, we're using the point of -4, 2, which is f. So we're using the point of F and the perpendicular slope to plug into this formula. So y minus y1, which is 4, negative 1/2 x minus x1, which is negative 2, so plus 2. So if I simplify this, I get, so you guys should be able to do this. This is algebra. Plus 3. So this line right here is one of the lines on this triangle. Now we need to find the equation of the line of the altitude from G to FH. We know that the slope of FH, so the slope, so we're doing the whole thing over for something else now. So FH is 1, 2, 3, 4, 5, 6, so negative 6, and then right 2, right 3. So this is going to be negative 6 over 3, which is negative 2. And if we find the perpendicular of that, that's going to be 1/2. So now we're going to do the same thing, but now we're using the point of G. So G of 4, 4. And this is our M. So I have y minus y1 equals m x minus x1. So I have y minus 4 is equal to 1/2 x minus 4. So if I distribute that, I have y minus 4 is equal to 1/2 x minus 2. And I add 4, I have y is equal to 1/2 x plus 2. So I have one equation, two equations. Now, in order to find where that point is at, I'm going to have to use systems of equations to find both x and y. And then that would be my orthocenter. So let me change my color here so we don't get mixed up. So I have y is equal to negative 1/2 x plus 3, and y is equal to 1/2 x plus 2. I'm going to use system of equations to solve. Well, since they are both equal to y, I can set each of them equal to each other. So negative 1/2 x plus 3 is equal to 1/2 x plus 2. Subtract 1/2 x to both sides, and I get negative 1x plus 3 is equal to 2. Subtract 3, and I get negative 1x is equal to negative 1. Divide by negative 1, I get x is equal to 1. Now I'm going to plug in that x value into one of my original equations. So I have y is equal to 1/2 times 1 plus 2. 1/2 times 1 is 1/2 plus 2. I get y is equal to 5/2. So that means my point, which is x comma y, is going to be equal to 1 comma 5/2. And this is my orthocenter of my problem. Orthocenter. Okay. So that concludes the notes for 5.2.